Good afternoon, everyone. Welcome to the Sustainability and Energy webinar series. Today we will be having Dr. Kate White, who is a civil engineer with the U.S. Army Corps of Engineers Institute for Water Resources. Her work incorporates anticipatory and adaptive management in the face of dynamic global changes such as climate change, so USACE will remain adaptable and sustainable over time. She co-leads the Yes. Can you hear me? Okay. She co-leads the USACE response to climate change program and represents the USACE on the Agency Adaptation Processes Working Group for the White House Council on Environmental Quality's Interagency Climate Change Adaptation Work Group, if you got that. Today is part one of two parts. Today we'll be setting the context and will include national policy, USACE governance, partners and programs, and existing USACE policy and guidance, as well as our trajectory. Part two of the webinar will be held on the 29th of April, same bat time, same bat channel. With that, I will turn it over to Dr. White.
All right, thanks, Eric. First, I just want to check again if the microphone sounds okay to you.
The microphone is working.
Okay, so I'll begin. So I've put a little outline here, and of course the slides will be posted so you can have them afterwards. They all have notes pages on the bottom, so you can come back and find hyperlinks and references that could be useful to you. But the things I'm going to talk about today are the ones that will set the context for the next talk, which is really about how we are responding to climate change. And I'm talking primarily about preparedness and resilience and adaptation. So first, climate is changing, will continue to change. I have a lot of background slides on this, only a few up front. The effects vary regionally, and they impact our missions and operations differently depending on both our missions and operations and the region that we're in. Next, I want to say that climate preparedness efforts really increased after Hurricane Katrina. So the Corps has been involved with climate science since about the 40s when we worked on some of the very early glacial ice cores, which laid the foundation for the current science of climate change. In fact, we're still working on drilling ice cores in Greenland and Antarctica. So the Corps does have a long history with climate change. Next is climate resilient infrastructure. We really need some creative thinking here, and I think the diversity of people on webinars such as this can, hopefully you'll see something here that will trigger something in you, and you'll start talking to somebody else and come up with some new ideas, and those are the kinds of ideas that we need to hear about. Preparedness is much more cost-effective than response. I'm going to show you just two examples of that, but I think the payback time is really quickly. Though we don't know exactly how much adaptation will cost, because we are mainstreaming it into our planning and engineering and design and operations. We won't really break it out, but I think we can say that we'll be able to figure out what the payback looks like in return on investment. And third, or last, policy and guidance are in development now. So let's see if there's a little bit of a lag. All right, I just have a few climate slides here. First thing I want to talk about is the fact that climate scientists really don't have any argument about whether there's anthropogenic or human-induced impacts to climate change. This little inset graph up here in the upper left shows in the black line is the observed CO2 concentrations in the atmosphere. The blue line, and shaded area because there's lots of different climate models and they have a different range of results. The blue line shows the results that you get if you use the natural forcings only. So this would be things like volcanoes, which tend to cool down the atmosphere. And the pink line is the range of climate models that actually include human effects, which are primarily due to emissions of CO2 since the Industrial Revolution. So we're talking about a 35% increase in production. Yep.
Yes. Your audio is kind of squelchy and a bit muffled. If you can make sure you have your speakers muted and maybe reposition the microphone.
Right now. Shoot. If I If I mute my speakers, you'll have to use the Q&A sign because I won't hear you.
Yeah, or maybe
Okay,
turn
so my
turn
speakers are
the microphone back down a little bit.
Does it sound better?
A little bit better, I think.
Yes?
Maybe a little further away.
Okay, a little further away.
Yeah, I'm just picking up a buzz when you talk.
Oh. How about now?
I think it's a little better.
Okay. Okay. All right. Sorry about that. So
somebody just posted and said it's worse.
All right.
It sounded pretty good earlier.
But it's just the two of us?
Yeah, maybe, I don't know, maybe it's a bandwidth thing. Let me see if... I'll try to mute my mic, but maybe if you can turn... It sounds like it's a little, like it's clipping. Maybe you can turn down the microphone.
There. Does that sound better?
Oh, yes, that's much better. Much better. Okay, I'll let you head back at it. Sorry for the interruption.
Okay, no problem. So, so the idea here is that the credible scientists are not seeing, there's no discussion, really seriously discussion, that there is not an anthropogenic signal for climate change. But the real issue that we have to face is when we look back in time using proxies such as the glacial ice cores and the sediment cores and looking at pollen samples and things like this, the records that have been reconstructed going back 800,000 years were actually beyond now the observed levels at that time. So now we're up past 2008, if I can move this little arrow, we're up in here somewhere. All right, and the issue is we can sometimes, if we were down in this range, down here, we could sometimes look back at the conditions at those times and use them as a way to estimate what the impacts will be for us. We're now beyond the record, so this is a real problem for us. All right. Next, we have multiple indicators that are measured over many decades to establish that the Earth's climate is warming. Now, this warming is not going to be simply an even global increase in temperature all over the globe. It's really changing in different places, and that depends on your location and also the signal that you're looking at. But the things that we're seeing are sea ice decreasing, snow cover decreasing, glacial mass decreasing, air temperature near the surface increasing, water vapor temperature, sea surface temperatures, sea levels rising, and ocean heat content rising. So these are all well documented. And all of them impact especially our civil works program, but also our military missions. Sea level change varies around the country depending on where you are. In locations where the land surface is sinking relative to the ocean, of course, the sea level range is much higher down here in the Gulf Coast. If you're in Alaska, in some places, the sea level is actually falling relative to the land surface. But hot spots would be the Gulf Coast and the Mid-Atlantic coast in here for sea level. Days over 100 degrees Fahrenheit are important for construction, for military training, for materials, for heating and cooling costs, especially for cooling costs. And you'll see that they tend to vary. So in different areas of the country, you'll see under different emission scenarios where brown is the historic, orange is a lower future emission scenario, and red is a higher future emission scenario. You see quite a range in the potential. But these are the kinds of things that we need to plan for now, especially when they impact materials and the projects that we build. Changing Arctic sea ice also impacts the core. We not only supply scientists to help monitor the sea ice, but we are also working, especially in Alaska, dealing with the impacts of less sea ice and more coastal erosion. Excuse me. Also, Great Lakes ice covers is declining, but as you can tell, it's not a really smooth line. It's kind of up and down, and these correspond to weather cycles. Weather cycles are much more rapid than climate cycles. Very heavy precipitation is another side effect of global warming, and that's because you have greater water vapor in the warmer air, and we have a precipitation event that can be very heavy. It's increasing, but again, it's not uniform around the country. So we have to plan for the U.S. average here wouldn't be very helpful if we were actually in the Great Plains South or in the Southwest. So we have to consider the very heavy precipitation that's occurring now. All of this means that we've made a commitment to a certain amount of climate change. There's a real lag in the difference between the CO2 equivalents in the atmosphere and the time it takes to realize the impacts from those. So if we look at the brown line here, this is the CO2 emissions peak. If we say this peak may be 50 years from now, if we then decrease these all the way down to this point, we would result in the kind of curves that you see here. So sea level rise due to thermal expansion, here's where we decrease the level of CO2 emissions. It's going to continue for hundreds of years. Sea level change due to ice melting, we're not really sure about what the magnitude of that is, but of course it would continue for a long time. Even for temperature stabilization, it would take a couple hundred years before we could stabilize after we decreased our emissions. So this means that we're actually committed to a certain amount of climate change. And this commitment requires both mitigation, which is avoiding the unmanageable impacts of climate, and adaptation, which is managing the unavoidable. So if we think about mitigation, it's this area in here where we're decreasing the emissions. And if we think about adaptation, it really covers the whole suite from now, which is right in here, all the way to the end of the time period. So if we're going to simplify it, climate change mitigation is largely about carbon, and adaptation is largely about water, though obviously there's some things like ecosystems. I'm going to tie them to water. For the core, Hurricane Katrina was really the event that pushed us back into taking climate change seriously. Hurricane Katrina, as you remember, was a very significant impact on the U.S. and on the Corps in particular, because General Strzok at the time noted that the Corps bore responsibility for the events of Hurricane Katrina. There were a series of internal and external reports dealing with the event. Two of them were the IPET, the Interagency Performance Evaluation Team report, and the second was an ASCE report on what must we do next. And both of those included a couple things important for us. One, we must have a consistent vertical datum around the country. People died because levees were too low because the benchmarks had sank. We didn't take subsidence into account, or there were errors in making conversions between different benchmarks. So we must have consistent datums. We must account for sea level rising, and we must take into account other changes that we know may be coming. So Katrina was very important for pushing the Corps' climate change program. So other thoughts that added to the program about the same time. First was the DoD Defense Science Board on capability surprises. There were actually two reports from this science board, and the idea was that extremes and surprises add complexity, and this was useful to us thinking post-Katrina because, as they said in the report, the biggest issue wasn't a failure to envision the events that could be a problem. We could envision the kinds of futures that might result from sea level rise and from changing precipitation, etc. But more important, it was which ones do you act on, and when do you act on them, and how strong a response do you provide. So these are the same kinds of things that impact the battle states that impact us in the Corps, and trying to figure out how to prepare for and improve our resilience to climate change. So in part they said that was because there's no systematic mechanism in place to help decide which events we needed to act on aggressively. And that really started us trying to really understand climate change in a way that it would be tied directly to our missions and operations to help us begin to prioritize response. So the next one is that water problems, which impact both the military programs and the civil works programs, are a class of problems called wicked problems, which comes from the early 70s economic literature and has been continued right up until today. But they're really difficult challenges. They're interdisciplinary interdisciplinary, and they integrate lots of different kinds of information. So you can't just have one type of person. It can't be simply a technical person. It needs the person who has the social sciences information, the math person, all the different kinds of information that we have available. And at the time, in 73, people said, you know, these are going to be making up more and more of our future challenges. And the complexities in nonlinear behavior, which is very much what we're seeing with climate change and responses, need something beyond the traditional approaches that were, you know, the status quo type approach. You can't just gather additional data. You can't just break it down into small problems. You actually have to dive into the problem, begin to understand it through the way that you're trying to solve it. So this really meant for us that we needed to be more active in our problem solving and our problem thinking. Next, we considered that sustainable development, which is tied to, obviously, the economic growth of the United States and our partners, is inextricably linked to climate change. The sustainability of natural systems and the economic systems that rely on them will depend on how well we can adapt to future conditions. And this means that our economic analyses that underlie our infrastructure investments are really key. We need to really understand all of the impacts that are going into those economic analyses so that when we make infrastructure investments, they're going to be sustainable, they're going to last over time, they're going to continue performing. So another consideration for aging infrastructure is that the level of investment in water resources infrastructure in the U.S. is about $400 billion. But how much do we need to keep it all working in the future? That's a multi-billion-dollar question, and we don't have the answers to that. There's a very active program going on in the Corps looking at asset management, public-private partnering, and other ways to deal with infrastructure in a new way that would perhaps take us more sustainably into the future. Another consideration is John W. Gardner, who was the first Secretary of Health, Education, and Welfare in the mid-60s and was very active in civil rights movement and was kind of he was the engineer of the early ecological movements in government. And I like this quote because it relates directly to the kinds of things we do, and that is the society which scorns excellence in plumbing as a humble activity and tolerates shoddiness in philosophy because it's exalted will have neither good plumbing nor good philosophy. And since we're essentially the plumbers for the nation, this really fits with us. We need to understand everybody's role in making the Corps function the way it should be functioning in the future. So that means everybody from the lock operator, the concrete revetment layer, the person working in planning in an office, the procurement people, I mean everybody, including the engineers. And another thing that John Gardner said is what we have before us are some breathtaking opportunities disguised as insoluble problems. And people sometimes ask me, am I kind of depressed looking at all the climate change information and thinking about the Corps as a something perceived to be stodgy? I don't look at it that way, but an agency that maybe is considered slow to move. And I actually think that we function very well under pressure and that we will be coming up with really good solutions in the future. And so I do feel like we have opportunities now, especially now before things really change too much. So keeping those thoughts in mind, the Corps had its first climate change adaptation policy signed in June 2011, and it told us that we need to integrate these activities into everything we do based on the best available and actionable climate science, and use this information when we're making long-term decisions. Our mission for climate change adaptation is to improve resilience and decrease vulnerability to the effects of climate change and variability. And we have a roadmap for that. We have 4 primary strategies. First is we've got to focus on priority areas. We need to make progress in areas that matter to the Corps. We need to engage in meaningful external collaboration. This is serious collaboration. We need to improve our knowledge for water resources management and infrastructure resilience, and then develop policy and guidance that can be followed, that can be properly implemented. So the approach really relies on policy and guidance based on consistent approaches that we develop with other agencies so that we're all working off the same set of data. We're working with the science agencies to translate that information into actionable science. the decision maker. We're developing tools and methods that the staff level can use to help ease and streamline planning, engineering, and decision making. We're conducting screening level assessments of vulnerability to climate change that are being refined over time as we get new knowledge, and we're incorporating training and capacity building. I think that another factor is that we're really relying a lot on geospatial tools because they support knowledge transfer, but they also help us streamline our planning and our design. We're all using the same information, and we're trying to develop climate tools that make this information easy to obtain. So another piece that occurred after our own policy was the President's Climate Action Plan released last June 25th. And this plan has three major pillars. First, it says that we must conserve energy and reduce greenhouse gas emissions. That's our sustainability and energy climate change mitigation work that's ongoing. We must prepare for adverse impacts, that's climate change adaptation. And then third, it says we need to stress our international leadership for both mitigation and adaptation. So this is something that I think that all the programs are going to be working on in the future. Next, in November, the President released Executive Order 13653, which is preparing the U.S. for the impacts of climate change. And this executive order says that changes are already affecting the U.S. and that the impacts are going to be most significant for communities that are already facing stressors and for the species and habitats already facing other pressures. So those aren't really surprising statements, but it does point out to us that as an engineering organization, we do have a very large role in public safety and public health and in making sure that the public understands the engineering choices that we're making. And if they're feeling stressed and they're already feeling impacts, then we need to consider that as we come up with solutions. So a few definitions from the executive order: preparedness and resilience, this ability to anticipate, prepare for, and adapt to changing conditions, withstand, respond to, and recover rapidly from disruptions. It's a little different from definitions we've used in the Corps, but nothing that we can't accommodate and internalize ourselves. It fits right in with the environmental operating principles and with the Corps' own adaptation mission. So now I want to get to, there's an economic case for preparedness. This slide here I got from the head of the New York City Wastewater Utilities, and they did a study post-Sandy. They said that based on the damages they had during Sandy, that if they consider their pumping stations in blue, their wastewater treatment plants in gray, and the total cost in orange, if they considered adaptation costs, no action costs, if they didn't do anything, and then risk avoided over 50 years. The no action cost is this is the value of their infrastructure now. The $315 million would be adaptation costs, and they would save $2.5 billion emergency response costs over 50 years. So that's a significant repayment, and it's one that New York City is taking very seriously. They're using some really creative ways to undertake that adaptation, and it's something that I think would be of great interest to IE&E and to the architectural community, some of the ways that they're developing these adaptation measures. So I do want to point out, though, it's not all about the big infrastructure. It's not all about the levees and the dams. A really important factor are things like culverts, right? I'm showing on the right a table from a DOT study, which is hyperlinked here, but somehow it came in blue and I can't read it. And I'm showing some case study information. This column here is I-70 in Colorado, and outlined here is the emergency replacement installation cost in 2003 dollars for one incident, and it was $4.2 million. Now, they estimated the cost to change to a 100-year pipe to make it a bigger pipe at about $12,000. So the idea here is, if you know you could be having problems in the future, you're doing routine maintenance, you can resize your culverts at a very low cost and save yourself quite a bit of money. So here's a couple examples of culvert failures that occurred last year in Colorado during the very heavy fall flooding. The reason that Colorado lost so many roadways is because of culvert failures. Kind of a small, often overlooked piece of infrastructure, but it's the kind of thing that we could really make a difference if we start considering other small pieces of infrastructure where adaptation could result in quite a bit of payoff. I think this one got stuck before. Sorry, I'm impatient. Okay, I may have missed one, but I think this is okay. The other thing is, it's not just about extreme events. It's not always the Sandy or the Katrina that gets us. The event I'm showing here is from 2009, June and July. There's a lot of mid-Atlantic coastal flooding. About every high tide, you'd have road flooding, like in the top picture. And what really happened when NOAA started to look at it very carefully was that two kind of typical events that were happening, nothing really out of the ordinary, but the way they combined really caused a problem. And this was the northeasterly winds were just increased slightly more than normal. And the Florida current, which transports water up from Florida along the mid-Atlantic coast up to the New England area, kind of stuttered a little bit, slowed down a little bit. The combination of the two really resulted in a lot of water being pushed up on the shore, and this caused flooding and damage. It's exactly the kind of thing that we could be prepared for when we monitor the Florida current, when we monitor the northeasterly winds. We could be prepared for it. We could also put into place fairly low-cost mitigation measures or adaptation measures that would reduce the damages. So when we start to think about how we're going to adapt to climate change, we sometimes think about the uncertainty in the projections for the future. And this little graphic shows that if you have a low degree of uncertainty and a low degree of risk, you're probably going to go to best management factors. In other words, if it's low risk, low uncertainty, you probably already know what to do. If it's low risk but high uncertainty, you might move to adaptive management. If it's high risk and high uncertainty, you may only be able to look at scenario planning. You may not have enough certainty to actually plan or design to one specific level. And then if it's low uncertainty and high response and high risk, you can move into preparedness and response. So we could kind of think about what our different activities are between these four quadrants. And for the core, for coastal areas, we said we're in the scenario planning area. It's high consequences in coastal for coastal shoreline erosion control and coastal risk reduction. Over 50% of the population is within 40 miles of the coastline, and we've got significant economic development in that area. So we moved to a scenario approach where if we're looking out over time here, and we're looking at sea level here, we have a low scenario shown in the bottom, which is just an extrapolation of the current tide, as shown in the little inset box. We've got an intermediate scenario, which is shown by the red curve. Then we've got a high scenario, which is the purple line. Our first guidance came out in 2009. It was updated in 2011. Those engineer circulars were replaced with an engineer regulation with the same approach at the end of December this past year. We also have an adaptation guidance that's been signed and is awaiting publication. That's Engineer Technical Letter 1100-2-1, so it's the first in a series of adaptation technical guidance. This guidance really relies on the user, the planner, the engineer, the stakeholder, to identify tipping points so that we can then back into the decision-making process. So this is an idealized version of that. We have an indicator value, which could be, say, sea level rise, and then this is over time. And so then the next thing we do is with our indicator value, we pick a threshold value where intervention is needed. This could be something like 1 foot below the top of a dune system, or maybe 2 feet below the top of the dune system, where you start to get really worried about the function and performance of the structure. And then knowing here in the blue line, knowing the past history, where the sea level has been in the past, and being able to project it into the future with these dotted blue lines, we can then make some estimate of what the lead time will be for planning and construction for different alternatives. And then we know where our decision point is. So we don't want to wait until we've gone over the threshold. We want to take advantage of the information we have about projecting into the future and the lead time to make our decision earlier so we are prepared. We're not responding. We get that benefit of preparedness. And on the teams that we're using to develop our guidance, we think collaboration is really a key element. First of all, the PDTs are made up largely of Corps of Engineers staff people from the districts. This is one that's just started off in February. This is incorporating sea level change in design water levels for coastal projects. So this would be the going up to the extreme event, that could be anywhere from the monthly to the 2-year to the 5, 10, 15, 20, 100, 250-year event. And on this team, it's led by Heidi Moritz, who's a coastal engineer from Portland District. We have experts from NOAA, probably the 2 top experts in the U.S. on tides, Billy Sweet and Chris Zervis. We have Kurt Sterlazzi from the USGS. We have Mark Kroll from FEMA, heavily involved in their coastal and climate programs. Dave Kriebel from the U.S. Naval Academy. We're getting a person from the Department of Transportation. We also have staff from H.R. Wallingford in England. Sorry about that. We have staff from the University of Southampton in England. Again, several district people. We've got Honolulu District, New Orleans District, Portland. We've got some ERDIC folks from the Coastal and Hydraulics, Environmental, Coastal and Hydraulics, Environmental and Coastal and Hydraulics labs. We have staff from Oregon State University. Excuse me. I figure out how to turn it off. We have a planner from headquarters. We've got a German expert from the University of Siegen. We've got an expert from the University of New South Wales in Australia. We've got a person from the Netherlands. So we've really covered the world on this guidance team. And this is the kind of information that when we put together a guidance, we feel confident that it represents the best actionable science and also the best perspectives of coastal engineers around the world. So the policy and guidance that we've developed to date include our overarching policy that I mentioned earlier that was released in June 2011. It's going to be updated in June this year according to EO 13653. With respect to those consistent datums, the vertical control that I mentioned, we have an engineer regulation, an engineer manual, and we have tools that I'll talk about on the next slide. For sea level change, we started in 2000, well, actually an engineering letter back in 1986, but our engineering reg and planning reg required us for sensitivity to different rates of sea level. And we had the 2009 and 2011 engineer circulars, which were replaced in 2013. And then in 2014, our engineer technical letter on adaptation is signed and people are using it. It's just in the ACIT publication process. We've also worked on developing a post-Sandy flood risk recovery standard to meet the requirements of an executive order in April 2013 in the Sandy area. And we're working on a hydrology guidance for inland hydrology. So next is tools. The tools kind of go right along with the guidance, and what we've learned is that we really need to release the tools at exactly the same time. So for datums, we have, based on core math, the core automated information system for geospatial information. We have a survey monument archival and retrieval tool, which sounds archaic to those of us who aren't into the surveying minutiae, but it's extremely important. And we track compliance with the datum standards. For sea level change, we have a sea level change calculator. It's available to the public on our web. We use this in supporting the interagency SANDY sea level rise tool, working with NOAA, FEMA, and the U.S. Global Research Change Program. We also allow that to be compared to USACE, NOAA, and any other scenarios. We've added the New York City Panel on Climate Change at their request and the National Research Council report on Western sea level change scenarios. So you can compare ours to anybody's if you want. We're working on a simplified method for these extreme water levels, the design water levels in development, and also more technical methods. We have a calculator supporting the flood risk recovery standard. We have in-prep regional literature syntheses and development to be completed this calendar year. I'm crossing my fingers on that one, but we think we'll get that. These will underlie planning and engineering design specifically for core business lines. We have developed a consistent nationwide set of hydrology at the HUC-4 watershed level. HUC is a hydrologic unit code designated by the U.S. Geological Survey. There's 202 of them for the CONUS. So we have this consistent set of downscale but unregulated hydrology for the CONUS, which we developed with the USGS, with NOAA, with the National Center for Atmospheric Research, Santa Clara University, Climate Central, and it's all housed on a public archive at the Lawrence Livermore National Lab. And we're developing a tool where you can just click on a watershed and pull this hydrology down for use in the study. And again, we're conducting these vulnerability assessments. So in summary, climate is changing. We're working to understand how this will impact us. We emphasize collaboration with science agencies, with other operating agencies such as the Bureau of Reclamation and other experts. And we are preparing now to improve resilience in the future, and we are implementing these changes now as we move along. And we need creative thought. So I hope that the volume actually ended up working out okay.
Thank you very much. Nobody's posted any questions yet. There's a Q&A box on the lower right-hand corner of the screen. If people aren't familiar with the interface, type in your questions there, and I will read them, and we will go from there. Also, on the left-hand side, there's a link to the Sustainability Energy website, as well as the DCO troubleshooting page if you have any trouble logging in. Of course, if you're hearing this, you already are in. Under that is the downloads, which has a copy of this presentation. One of the slides had a link on it that if you wanted to download that, you could follow that link to the additional information. People interested in CEUs, there's information in the text box on the upper right about answering the quizzes on the Sustainability and Energy website for every 5 sessions to get your CEUs. Lindsay Pruitt is the point of contact for that, and her email address is there. And again, she's in the global. So I don't. Okay, here comes a question. Let's see, Julie. Are potentially impacted coastal installations reworking their master plans to accommodate sea level change?
Oh, okay, that's a good question. So that question is a question that really would end up going to IE&E over an Army, because the Corps' military missions in that area supports the Army, but we've got policy for the Corps' Civil Works program, and we're evaluating the projects on a project-by-project basis, screening them for further detailed study. The Corps doesn't write policy or guidance for the Army in this case. So, so that's out of my area of expertise to answer.
Do we have any other questions from the field? I don't see any in the text box. Okay, here we go. MOK, let's say, looking at the chart on slide 28, should we assume a new facility built for the long term should be raised? RAISED.
Let's see. Let me go back to that chart and see 28. Oh, that must be our sea level curves. Sorry. 15 minutes to get back. Okay. So you're talking about this particular chart. We have our Corps of Engineers planning horizon. It really depends on what kind of a project that you're looking at. We've been working under this guidance now since 2009. We've had a number of projects come up through Civil Works going through the Chief's report. These have included ecosystem restoration projects in the Gulf. They've included, just trying to think of some of the reasons. One was a combination dike and ecosystem restoration project in South San Francisco Bay. Navigation structures, jetties, beaches, beach and dune systems. And so it depends on the kind of project that you're looking at and what's going to be happening over time. But the way we tend to look at these is we tend to look at the critical elevation. Remember, I said that green thing. Well, I can't get the green arrow to come. Maybe I'll try the infamous drawing thing. Oh, there it goes. There's a lag. Anyway, we look at the elevation, the threshold elevation. Then we look across and we see when we might hit the various different kind of sea level change. And don't forget, on top of this sea level change is those the design water levels. So that would be on top of these. And what we do is identify what would tip it into the non-performance state. And we decide whether the project as we formulated is robust to these sea level changes or not. In some cases, we've decided that, for example, for an ecosystem restoration project, that it's maybe robust to the low and the intermediate scenarios, but it isn't robust to the higher scenarios. And in that case, we might say that it's not the type of situation that you want to try to engineer your way out of. In other words, we don't want to continue providing land for that ecosystem to migrate inland, because by the time you reach that high rate scenario, the entire coastline would be underwater, and it would be more of a policy decision on where to hold the line or where to continue investing. So that's kind of something important for the way we use this guidance. In some cases, it might say, yes, indeed, say we're working on a non-structural flood-proofing. It may be that we'd have to raise the elevation of the houses or the structures at that point. Does that answer the question?
If it didn't, they can follow on with another question. Otherwise, we have another one from Ned Shepard. Some USACE responsibilities with regard to adaptation can be envisioned. What, if any, USACE responsibilities do you see with regard to mitigation?
Okay, so mitigation. Actually, the Corps, I think it's safe to say that the Corps has a vibrant sustainability and energy community that's working very hard on mitigation, because they're looking at all those the energy conservation, the sources of energy that we're using, looking hard at how we can meet the targets that have been set by Executive Order 13514. So Antonio Giardina and John Coho are the leads in this effort, and since that's been actually going on since about 2010. And they've seen some reasonable reductions in energy intensity and use, and there's quite a community of users in the district who are trying to come up with creative ways to reduce those greenhouse gas emissions. We also have a group of people that are evaluating our land and water resources to see if there's a potential for us to sequester carbon in the land and the water, and the way we manage that, so that we could maybe prevent some emissions from occurring. One issue that we have is that a common way to sequester carbon is to simply grow trees, and the problem is if you grow trees in an area that's threatened by wildfires and invasive species like the bark beetles, then you're only looking at a temporary sequestration. So we do have a group looking at that, and over the next few years that should roll out around the Corps, out from the pilot sites, so that people can make their own estimates.
Okay, this is a follow-on question, and I'll dovetail it with some thoughts I had myself. With regard to design criteria. Right now we're designing for the 100-year floodplain. Should we consider adding additional feet? Likewise, I was thinking if we have more extremes in weather, should we be looking at changing the criteria we use for snow loads on roofs or wind loads applied to buildings?
Oh, those are super questions. Okay, let me start with the snow and the wind. Interestingly, the way the snow is going, it's very elevation related, so that higher up in the mountains, it seems like initially people were thinking, say 5 or 10 years ago, that snow was just going to be decreasing all the way up. The bottom, the snow line would be raised in elevation, and then above that, we'd just get the same snow volume, so you'd really be decreasing the total volume. But in some cases where precipitation is increasing, we're seeing an increase in the volume up at the very tops of the mountains. So we don't know enough about that to say how it would affect the snow loads, but I do know that the snow loads are undergoing review right now because they're pretty old. I remember looking at them in the late 80s, and at that time they were questionable, but they are being looked at. We have more modern methods and tools that we can use. Wind loads, We have a team working with top investigators from Princeton, from Climate Central, from Lawrence Livermore, from Los Alamos, from several locations in New York, Stony Brook. This team is working on the Sandy recovery, and they're looking at the storminess, changes in storminess, and they've got some people from Australia and the UK also involved in reviewing that work. So eventually we'll know something about the wind, the changes in wind, but at the moment we don't have enough to say whether we need to change our codes. Now we go back to the 100-year flood. Now it's interesting because the 1% flood, or the 100-year flood, as many people call it, that might delineate the regulatory floodplain for the National Flood Insurance Program. It's mentioned in the Executive Order 11-988, I remember the name of, which is dealing with, really asks us to consider flood conditions or flood elevations as we develop infrastructure. But the Corps itself, on the civil works side, doesn't design for the 100-year floodplain. We plan and formulate projects. We evaluate them using economic assessments as required by the principles and guidelines for water and land-related environmental planning. I can never remember the whole name, but principles and guidelines. So we conduct those economic analyses, and those usually end up resulting in the kind of project that we end up with, which may be below or above or entirely unrelated to the 100-year floodplain. On the other hand, the Sandy flood risk reduction standard in the Sandy area requires major federal investments to look at 1% flood plus 1 foot, or if there's a more restrictive local requirement, then we have to look at that. Now that's for our 4 walls and a roof kind of infrastructure. It doesn't apply to our horizontal infrastructure or our natural or nature-based infrastructure such as a beach and a dune. So it's a little complicated, but there's another interagency group going on right now that's trying to come up with some kind of a standard to increase our resilience to potential future increases in flood.
Okay. Mary writes, how might climate change affect water quantity or availability issues? What strategies or design considerations could be used to mitigate or adapt to any climate-related water scarcity issues?
Oh, that's a really huge question. So one of the first things we knew back in 2009 when the Corps, USGS, NOAA, and Reclamation published USGS Circular 1331, which was the federal perspective on water resources and climate change. That document, water availability and quantity and availability was really important to us at that time. The Corps has over 700 dams. We have water supply authorized as a purpose for many of them. We don't own the water. We merely store that water, and it's allocated according to often congressionally authorized purposes. On the other hand, you can't help but face the political pressure to release water. If we look at the 2012 drought in the Mississippi River, we had a lot of pressure to release flows from the Ohio, which wasn't suffering so much from drought, and to release flows from the Ohio so that navigation on the Mississippi would be unimpeded. And the issue was that our water control manuals on the Ohio and our drought contingency plans did not have navigation as an authorized purpose for releasing water during periods of drought. So it's interesting there because water supply is the primary authorized purpose in Ohio, and they said we've got to hold the water here. We've got to be able to meet the demands of the cities that hold the contracts for this water. So we've had, going on for about 3 or 4 years now, a PDP, 4 district people working on a drought contingency plan update. They've actually collected all the drought contingency plans, made them all electronic, made them available via portal on Core Map. So you can go to this map, you can draw up the locations of all the dams. You can click on a dam and up comes a summary of its drought contingency plan, and then you can pull up the electronic version. You can also pull up the core water management plots for whatever period of time you want. Starts with the current and moves back about a week. So you can see exactly what kind of water levels we have in the reservoir and how those compare to the different authorized levels in the reservoir. And we're adding in reclamation dams because we often work together, especially during drought and flood, and other dams. So we're preparing tools that will help us begin to lay out new policy and guidance about drought contingency plan operations during periods of drought. I hope that was useful. But that's a central issue.
Okay, I have a couple follow-on questions from Julie and Ned, which I'm going to combine into one. Basically, looking at selecting building components, energy modeling, and use projections for the economics when making decisions on long life cycle building systems. Is anybody working on addressing those changes in the climate affecting those life cycle cost systems? And likewise, Ned is asking if you anticipate that the social cost, capitalized, of carbon will be adopted officially, which would allow us to include it in life cycle cost analyses.
Okay, that's a great question. I'm going to start with the second one. The social cost of carbon. There was a tremendous piece of work done by the British, gosh, maybe 5 or 10 years ago. It seems recent to me, but I think in 2009 it was fairly recent. So somewhere between 5 and 10 years ago, social cost of carbon was done in the UK, which really looked very carefully at those costs for use in those kinds of analyses. In the US, there was a parallel effort. It never got the exposure that perhaps it needs, but I think you can still find that it was done for CEQ, and I believe that under the President's Climate Action Plan that there will be some effort to bring that back into focus, the social cost of carbon. If they can't pass a bill in Congress dealing with those issues, they can at least have the federal agencies consider them, as they've had us done with the energy conservation, water conservation, greenhouse gas emissions reductions under 135 and 30. I will add, though, that the General Services Administration has a very active climate change adaptation group, and they are looking at exactly the kind of building life cycle analyses that you're talking about. And I can, what I could probably try to do is maybe connect some people with their climate change adaptation folks and maybe have them come and give a talk if you want sometime. We've got a super team. They're right centrally in the area of that question, and they're coming to us for help in other areas, like our sea level calculator is very useful for them to look at future potential risk for their asset locations.
Okay.
So really good
That's all the questions that are on the list at the moment. It's wrapping up at 5 till. So I think we'll thank you for your participation, everyone. Over 30 people called in. Also, thank you to Dr. White for her time and giving us information today. Again, I believe you're on the global address list if anybody has any follow-on questions. Otherwise, the webinar is recorded, and we will have it uploaded to the Sustainability and Energy website. The link was in that announcement email, as well as being on the left-hand side under web links there, the first link. Thanks again, all. And with this, I will close down the recording, and I'll leave the website up for a little bit if people want to download that presentation down there on the bottom left to have your own copy and to look at the links that were in it. And have a